Good day everyone, I'm Budget from Group 6. In this presentation, we will present on the data modification, data modeling, data assessment, and lastly conclusion for our report for which entitled Telemarketing Campaign Prediction. Before we start, let's highlight again for the objective in this project. In previous part, we have evaluated the effectiveness of telemarketing campaign and identified the profile of the term deposit campaign takers. So in the following, we will focus on developing the prediction model to predict whether a client will subscribe the term deposit. For the data modification part, first in the modifying and correcting source data, we first removing the outlier from the column previous with filter not in SAS enterprise minor. The upper limit is set to the 60 and one observation was removed. Then we derive the missing column of year extract from the column date to the dataset with talent.
Continue with data modification. According to the result of exploratory analysis, we found that there is an obvious imbalance in the target variable. We decided to solve this problem with undersampling and implemented it with SAS code node. On the left is the source code. We will randomly select symbol from the category with bigger symbol size, make the symbol size of two categories equal. On the left is a sampling result of the category with more symbols. The sample size is 5,289. Then we need to merge it with the data of the another categories. So our completed sample size is 10,578.
Before the dataset entering for the model into the modeling step, dataset will partition into 50% for the training dataset and 50% for the validation dataset. And here is the output for the task. And also we remove the column balance from the dataset as the variable balance was proven not have no impact to the target variable in the previous section.
Hi everyone, I'm Sanyu. The next section is data modeling. The first classification model we used is decision tree predictive model. I set up 5 different decision tree models with different maximum dips. The dips is from 4 to 8. First, the model needs to connect with the data source and training the models, and then I will do the evaluation and compare the performance of each model. The next part is to evaluate and compare the models. From the table, I can see that the accuracy of the model increases and the depth of the model increases. When the depth of the model reaches 7, the accuracy of the model is no longer to improve. When the depth is 7 or 8, the classification error range of the decision tree model is the lowest, which is 0.113654, and the accuracy is 88.64%.
To apply logistic regression model on the dataset, 3 regression node is added into the flow diagram as each node is assigned with the different feature selection method, which are forward selection, backward selection, and stepwise selection. From the result of each regression node, we found that the features selected into the model are the same, which are the variable date, duration, month, P outcome, housing, P days, job, campaign day, and marital. And since the features selected are the same, so it implies that there is no difference to select either one of the logistic regression model. Thus, logistic regression model with the stepwise selection is selected in the following section. From the statistical result for the logistic regression, the misclassification rate for the model is 14.58%, implying accuracy of logistic regression model is quite well with 85.42%. Besides, the result also show that the model is a good fit model as misclassification rate and for the training and validation set are close to each other. From the effect of features in logistic regression, there are three major things three major findings in our study. First is the variable month March when increase one unit, it will increase the probability of the customer subscribe the term process by 5%. And the second one is when increase in one unit in the variable P outcome as success, will also increase the probability of customer to subscribe term deposit by 3.54%. And lastly is when we increase 1 unit in the variable month October, it will increase the probability of customer to subscribe a term deposit by approximately 2%.
Hi everyone, I'm Chen Baogang. I will continue with the modeling phase of our project, and I'm going to present the neural network module. When it comes to training our data with a neural network, we can start by dragging and dropping 11 neural network nodes from the module tab into diagram. This will allow us to build multiple neural network modules and explore the performance. Then we rename each node according to desired hidden layers. Start with the first node and rename it as the 4 hidden layer neural network. Then continue renaming the remaining nodes, such as 5, 6, 7, 8, 9, 10. Then we connect each neural network to the control point node. Finally, we connect the control point node to model comparison node. Next, we set parameters in each neural network node. First, click Network in Property. Specify the number of hidden units for each neural network node. For example, for the 4 hidden layer neural network node, we set the number of hidden units to 4. Lastly, we save the changes and run this neural network node. Among the evaluated modules, the 5 modules with a noise classification rate are those with a number of hidden units set as 5, 6, 8, 9, and 10. However, the misclassification rate of neural network nodes with 4, 7, 15, 20, 25, and 30 hidden layers are quite high. We also found that 8 hidden layers of neural network has a noise classification rate of around 0.1257, which gives an accuracy of around 87.42%.
Hi, I'm Shiling. The next modeling use is gradient boosting. Gradient boosting is one of the assembly methods in machine learning that proven to increase the model accuracy. We set the lead fractions at 0.01 and the maximum depth level as 4, 5, 6, and 7 respectively. The result shows that the gradient boosting at the depth level of 6 has the lowest misclassification rate of 10.9%, followed by the depth level at 5, 7, and 4. Gradient boosting also shows that duration, date, and month are the important variables in predicting the term deposit takeout. Now we have completed the modeling using logistic regressions, neural network, decision tree, and gradient boosting. Let's assess the model performance. Let's assess which model gives the best performance. We first look into decision tree. Decision tree with the depth level of 6 has the lowest misclassifications and hence being selected. On the other hand, for logistic regressions, all the logistic regression has the same misclassification rate, hence it's indifference. For neural network, 8 layers of neural network has the lowest misclassification rate of 0.12 and hence is being selected. Lastly, on the gradient boosting with the depth level of 6 has the lowest misclassifications. Now, among all the best models from the different modeling technique, we have then concluded that gradient boosting has the best performance with the lowest misclassification rate among all and hence the highest accuracy of 89.07%. Conclusions. Data modification has carried out based on our findings from the previous data exploration stage, including removing outliers, derived missing columns, and also data balancing. Now, we have using the 18 variables that are identified has been relevant in the modeling. With our analysis objective that it is to predict which client will subscribe to a term deposit, we have concluded that gradient boosting model will be used as it has the highest accuracy of 89%. The assessment method used in gradient boosting efficiently decreased the bias area, and hence it is not surprised that this is the best model. Throughout the modeling, we have also found out that duration, date, and months are the top key features in predicting term deposit takers. This is coming from decision tree and gradient boosting. Thank you.